10, 9, 8, 7, 6, 5, 4, 3, 2, 1, 0.
Good morning on this lovely Saturday, and welcome to the UJ International Day of Mathematics events.
Today's program is made possible by NITheCS and the NRC,
as well as the South African Mathematical Society, the South African Math Foundation, and the NRF SAASTA.
My name is Dr. Serene Rathilal, and I'm a lecturer at the University of Johannesburg's Department of Mathematics and Applied Mathematics.
And I am Dr. Lungiles Tole, and I am the senior lecturer and director of the UJ Soweto Science Centre, and we are your hosts for today's events.
To kick off today's program, I would like to introduce you to the HOD of our Department of Mathematics and Applied Mathematics. I just want to quickly confirm, has Prof joined us? Not yet. Well, nonetheless, as he joins, I would like to tell you more about him. So our HOD, Professor Nyabatsa, holds a PhD in applied mathematics, which he obtained from the University of Botswana. His research focuses on the application of mathematics to disease evolution and control. His research interests are also emerging infections, vector-borne diseases, and modeling crime dynamics and modeling drug abuse. Professor Nyabatsa is an internationally recognized mathematician and editor of 4 highly ranked journals in the field of biomathematics and mathematical biology. He has successfully supervised 14 PhD students and 56 MSc students. He is passionate about training future mathematicians. So Prof. Nyabatsa, I see you've now joined. We now hand over to you. Thank you.
Thank you so much, Serene, and greetings to everybody. And I'm glad I can see faces that I can identify. And I see Zurab and the other guys there. Thank you so much. I really appreciate. And maybe I should first say thank you to the organizers of this event, in particular, Dr. Rathilal and the sponsors and all those that are involved in setting up such a thing. Now, the Department of Maths and Applied Maths is actually delighted to have you guys being part of this wonderful initiative as we celebrate the International Day of Mathematics. It is always a pleasure to have such kind of an event, linking up with colleagues from different parts of the country. I'm not so sure if I should say different parts of the world, but I guess this has mainly been something that is within our borders. And I would want to welcome, and on behalf of the department and on behalf of the faculty, these are events that the faculty is always happy to hear about them. And for your own information, I think on the 14th, I got an email from the dean asking us, or asking me that this is the International Day of Mathematics. What is your department doing? And she was delighted when I told her that we have this particular event and our newly appointed marketer is actually in the loop, and she is, on it and covering it. So it is actually a pleasure from my side, representing the department. I want to welcome you all, and I am looking forward to deliberations that will ignite our passion in mathematics, that will ignite, give us some energy with regards to this particular subject that we so love so much. And let this time be a time of engagement. Let this time be a time where we will link up with colleagues, where we will discuss how good it is to be part and parcel of this particular program. To the young ones who could be part of this, or who are part of this grouping, let me just say you are very much welcome. The University of Johannesburg looks forward to welcoming you as you venture into a subject such as mathematics. It is actually, I feel delighted. I'm seeing we have 220 participants at the present moment, and I'm looking forward to having them coming more and more, and such kind of an event. I know I will have a discussion with the team that is organizing that this event be actually a huge annual event that can extend further, even beyond our borders. And I'm actually so delighted to welcome you guys. I see the numbers are actually increasing of our participants. Welcome. Thank you so much. I am delighted to actually be representing a department with energetic individuals that that are so energized to propel or propagate the subject of mathematics, especially in this country and in this province. So thank you so much, everybody. And I wish you a wonderful engagement as you do your quizzes, a wonderful engagement as some of you win prizes, a wonderful engagement as as we continue to share. I know Professor Mumunyat has got a wonderful presentation that is prepared for us. And from my side, on behalf of the department, thank you so much, everybody. And I wish you, a blessed event. And I will certainly see you on the side of the closing ceremony. Thank you so much. And I wish you all the best. Back to you, Sarine.
Thank you, Prof. Nyabata. Thank you so much for the warm welcome. I would like to now introduce our next speaker, who will also be giving us a nice message and a welcome, Professor Kirsten Jordan. Professor Kirsten Jordan started her career in 1991 as a mathematics teacher at Pretoria High School for Girls. Professor Jordan is a full professor in mathematics at the Department of Decision Sciences, which is at the University of South Africa. She is also part-time executive director of the South African Mathematics Foundation. Professor Jordan served as the president of the South African Mathematical Society from 2016 to 2019. She also holds a Royal Society Newton Advanced Fellowship for her research in special functions and orthogonal polynomials. Professor Jordan is also one of only 3 women in South Africa to be evaluated by the National Research Foundation as a mathematics researcher, and she has considerable international recognition. Professor Jordan, I don't want to say too much more, but please, I welcome you. The stage is all yours.
Thank you very much, Nambili, for that introduction. So welcome to everybody from the South African Mathematics Foundation. I want to share just some ideas with you. And I'm going to take you back to something that I was involved in when I was at school. I'm not sure whether they still do this nowadays, but when I was at school many, many years ago, we went on week-long camps that were known as veld schools. I think, if I remember correctly, I went once in grade 6 and again in grade 11, possibly more, but I particularly remember the one in grade 11. So we did many interesting things, but the grade 11 one, we were somewhere in the bush, sleeping in dorms. And on the one day, we had to do a sort of wilderness trail obstacle course in smaller groups. So there was rivers and trees and all kinds of puzzles that we had to solve. The obstacles were really interesting. And some actually posed quite difficult problems. And we had to solve these to be able to proceed. I wish I could remember all of them exactly, but one of them I remember something like finding a way to cross a river. There was no other way to cross it, and all we were given was 2 or 3 poles and a rope. And then we had to solve this practical problem about how we're going to use those tools to now cross the river. I really enjoyed this challenge and actually found that I was quite good at solving these kind of practical problems. I think I helped my group solve quite a number of them. So you may be wondering why I'm talking about this, talking about CALD schools, and what it all has to do with mathematics. Well, at the time, as I said before, I was in grade 11, and I was achieving quite reasonable marks in all of my subjects, but I actually had no idea that I had a special talent in mathematics or in problem solving. It was only many, many years later that I realized this, and I learned to develop these skills. So a significant number of skills that are needed today to thrive in the job market in our present era that they refer to as the fourth industrial revolution, they are linked to problem solving. And mathematics, by teaching you mathematical reasoning, logical reasoning, cognitive flexibility, and computational literacy is really the ideal vehicle to develop your ability to think out of the box. In other words, to find strategies that have not been shown to you before that solve a particular problem. So when I talk about this kind of mathematics, I'm not talking about what you learn in the classroom, like, for example, if you're in grade 11, I think, learning to complete the square, or the type of technique that you can mostly master by knowing what procedure or algorithm or rule the teacher told you to apply, and then you just follow that. No, I'm talking about different kinds of skills. I'm talking about developing the thinking skills that you need to solve non-standard problems, something that you haven't been shown before. So how do you learn these kind of skills? Well, an effective way of being exposed to problem solving is through participation in mathematics competitions. These competitions include questions that you would have not generally seen before, and for which standard taught procedures will not be sufficient to solve the problems. There's an official national event that you may have heard of, namely the South African Mathematics Olympiad, which is organized by the South African Maths Foundation. Many people think that these competitions are just for the bottoms, but it's not true. So there's very many different levels at which you can participate and be exposed to the kind of problems in this competition. The first round for this year has already been written. So if you are interested in participating in the future, or you would like to improve your problem solving skills for next year's competition, we have an app, the Maths Foundation. I'm just going to share my screens quickly so that you can see what I'm talking about. All right. This app is called mytutor.chat. So it's what's in the bottom left corner there. And apart from this app, which you can download on your phone, and you have exposure to over 1,000 type of problems that teach you exactly these kind of problem solving skills that are not really linked to your school curriculum. We also have a mathematics talent search, the SAMF talent search, that makes use of the app. So for this year, you can still join the talent search now, even though it already started in November. You'll see it continues until May. Or you can simply just choose to download the app and use the app to start practicing your problem solving skills. The app adapts to your own skills. So as you solve problems, if you're struggling, it gives you easier problems, or if you're managing the problem that it gives you quite easily, it gives you harder problems.
1 minute, Prof.
Thanks. So you can use this to practice and develop your own talents. And in any case, they're fun problems, and it gives you exposures to this kind of thing that goes beyond the curriculum and is exciting and interesting, and teaches you the kind of skills to actually do well in our competitions. If you do well in the talent search, you could very well be selected for our training programs that are all free. So I would encourage you to have a look at this. If you want to know about the SAMF talent search, you can just simply Google SAMF talent search, those words in the blue heading. I thank you for listening, and I hope that you all will participate in our competitions in the future, and I trust that you will enjoy this day as well. Thank you very much, Nogile. I'm done.
Thank you, Prof. Thank you so much. I would like to now introduce our next speaker. Before I do so, just some information about where to type in your questions. So we have a Q&A box. We also have a chat box, which everybody has already been using. Thank you. It's exciting to see what you guys are writing in there. But for questions, please do type in the Q&A. All right, so our next speaker is Professor Ibrahim Momaniat. So Prof. Ibrahim is a professor in the Department of Mathematics and Applied Mathematics at the University of Johannesburg. His main area of research are mathematical modeling, fluid dynamics, and computational mathematics. Professor Ibrahim, on to you.
Thank you, Lungile. Good morning, everyone. I'm just sharing my screen. So welcome to my talk. It's on the role of mathematics and applied mathematics in 4IR. I just want to quickly have a look on the left in case you don't know why these organizations would actually be involved. So today is the International Day of Mathematics, the University of Johannesburg. And if you look there, there's an organization called NITheCS. NITheCS is the National Institute for Theoretical Physics, and then it's computational or computer sciences has been added to that. The NRF, that's the National Research Foundation of South Africa. When you get to university, especially at the higher levels of study, so honors, masters, PhD, you would normally apply to the NRF for funding. Here you would apply with a proposal. You would say what you want to do. Your proposal would be essentially evaluated by peers in the field, and depending on how successful your proposal is, and if it's supported, you'll get money to pay for your studies. So when you get to anything in mathematical sciences, physics, chemistry, at the higher levels of study, so this is beyond your degree, you'll find that there's a lot of funding available for you, especially if you are a good student, so you've performed well over the years, and you have the support of your head of department, your lecturer, your supervisor. The South African Mathematics Society, you've heard that Prof. Kirsten Jordan was the president of SAMS. Shireen, who is a co-presenter, is also on the SAMS Council. So SAMS essentially is responsible for looking after mathematicians at a very high level. We usually send our master's, PhD students to participate in the South African Math Society conferences. And it's a very supportive organization. So when you become a mathematician, those of you who are thinking of it, you actually join a big family. It's a very diverse family. Like all families, we have our ups and downs. But it is a family that's there to support you. The South African Math Foundation, Prof. Jordan spoke about what they do, in particular the maths competitions. And then the Northcliff Rotary Club. Now, Rotary, if you don't know, does a lot of outreach work, assistance in communities in need, etc. So if you look at just the labels on the left, it gives you an indication of the breadth, I would say, and depth of support you can receive if you are interested in mathematics, if you want to take mathematics further, if you want to use mathematics to make a contribution to society. Now, my talk speaks about the fourth industrial revolution and what is the fourth industrial revolution. And what I thought of doing was maybe just showing you that our interaction with the environment is usually what leads to innovation. Okay, so you can't speak about 4IR without speaking about innovation. So if you look at this picture on the top here, you'll see this is an Egyptian trying to get water from the Nile. One of the first lever and pulley systems was developed by the Egyptians. And the reason they needed this was to get water from the Nile, lift it up, pour it onto their fields. The next big innovation would be trains with steam engines. The reason we needed trains was as society spread, in many countries, you moved from city to city, you needed a way of transporting goods, you needed a way of transporting people that was cost effective, it was cheap, and it was, I would say, reliable, right? So the things that we're looking for especially when you're trying to do innovation. Think of reliability, right? You need to know when a train's going to arrive at a station, when is it going to leave. You need to know, for example, that if you do build this device, what is the depth of the water, or how low will the Nile River go, and how high will it go? Now, the Nile River is well known for flooding. So essentially, when it's flooding season, you wouldn't need this lever. You would generally need it maybe before or after flooding. And then if it drops further, well, your lever won't work. So it's all about thinking about how you interact with your environment and use technology to take advantage of your environment. Now, first industrial revolution, water and steam. Second, electric power. And then the third is the digital revolution. Fourth industrial revolution is what we'll talk about. Now, these are just labels, right? So don't get hung up on a label. Rather look at the opportunities presented by, in fact, being alive at this time. So, in fact, one of the definitions that I found, which I thought was very appropriate, is that 4IR is technology, refers to technology, AI, robotics, cloud computing, drones, Internet of Things. So again, it's essentially how we as people interact with technology, right? Robots doing work, you have many devices. You may be aware of some, you may not be aware that some of these devices are actually communicating with a cloud of information, collecting information. Your cell phone collects information about you all the time, how many steps you take, right? For your cell phone to tell you how many steps you've taken, it needs to record lots of other information to be able to get to the number of steps, right? So it's got a compass, it's got a gyroscope, which tells you which direction the phone is facing. And so to build up these technologies requires a lot of basic knowledge, I guess you could say. And a lot of that is driven by mathematics, right? So to get a gyroscope, to speak to a compass, to speak to a GPS, right? A lot of that communication that happens is based on mathematics. Most cars these days have got a tracker that essentially monitors your speed, distance, your trips, etc. So your tracker can actually be used to tell you, look, you drive too fast, you drive too slow. Okay, it never complains about driving too slow. If you want to know where your children have been, if they've used your car, well, the tracker will tell you. Okay? Factories in terms of outputs monitored all continuously. Smart watches. Most of you have seen the Apple Watch. There's a Huawei watch, a Xiaomi watch. Right? These watches record many things about your health, your heart, oxygen supply, etc. And all of this needs mathematics as a basis, because essentially it's taking digital, converting it into a signal. That signal has to go into an algorithm. The algorithm has to then speak back to the watch or to the phone to say, okay, all this information I've collected means that this person is having a heart attack. Right? Maybe, maybe not. But essentially that's where this is headed. You can monitor your plants, anything in the environment, farms, etc. Farms these days, farmers use drones to fly over their crops to make sure everything's okay. They use sensors in the ground to tell them whether or not there's enough water in the ground. So all of this is happening continuously, right? So lots of information is being generated here. Okay. Now, why mathematics? So Prof. Jordan hinted at this, where she said that maths helps you to solve problems. It helps you to quantify, interpret data, comprehension of text. You know, those word problems that all of you probably don't like? That's very important because what it does, it teaches you to take language and convert it into mathematics. Debating, right? How do you argue from a factual perspective about something? Project management, personal finance, and the importance of mathematics, statistics, all of the mathematical sciences is, as I've said earlier, in terms of sustainability and environmental conservation. So it's how we interact with the environment. or how can we better interact with the environment? So electric cars, self-driving cars, etc. All of that depends on mathematics. And this is another comment made by Prof. Werner Olivier from Governing Beckham Mathematics Development Center. It's that mathematics helps you to solve real life problems. And this is needed for job creation, sustainable economic growth, etc. I almost want to say the days are where you as young people actually go out to a company to get a job are probably diminishing, and it's more important now that you look at innovation, innovating yourself, finding a problem in your community that you can solve, and then finding a way of turning that into a business. And so that's the step into innovation. Another comment is that what many learners and parents fail to realize is maths and science are enabling subjects, right? So if you do maths and science and you do well at them, they actually open doors for you. If you think of problems that maybe your parents had to face versus things that you have to face, now these are problems at work, not necessarily other kinds of problems. We have this complex environment that we live in, where to go from A to B requires you to know something about where you are, the space, the path that you need to take, etc. A lot of this has to do with a subject called topology, which is pure maths. A lot of it is computing, which is applied maths. So these subjects speak to each other. In economics, you had supply, demand, and then suddenly you have the impact of a rumor, right? How powerful is this rumor? We heard that Russia is going to invade Ukraine. Okay, what does that mean for supply and demand? Whoops, we have a shortage of supply, which means the demand is going to go up, which means petrol, food, bread, all those costs go up. Right? So to model this, you actually do need mathematics. Okay. AI in particular, the World Economic Forum, they meet once a year in Davos. The importance of AI computing has become a much bigger issue than it was before. By 2022, 75 million jobs will have disappeared and replaced by 133 million new jobs. These new jobs are all based in AI, machine learning, computing, problem solving, environmental sciences, all of that. These are the new jobs. So by freeing up workers, it creates the space for us to work on other things. So if you think about us having time to look at global warming, for example, you need time to sort your garbage. You need time to really look at how you're living. Look at the number of plastic bags you use, for example, right? Are you living the best way possible that's a benefit to the environment? If you're working 18 hours a day, you don't actually have time to think about that. But if you can carve out time for yourself, your family, you can actually address those issues at a local level, at your home, at your school. And then it becomes an advantage to you that you don't necessarily have to work 18 hours. And in fact, in some countries in Europe, they don't work 5 days a week, they work 4 days a week. And productivity hasn't decreased, it's actually gone up. So that just shows that time is not necessarily the variable you need to use to model how successful you are at work or in business. It's how well you use that time that is becoming more and more important. And the interdisciplinary lens. So the other thing Prof. Jordan spoke about was the fact that you'll be in teams, right? So mathematicians need to work in teams because you will give the maths or the statistics. You'll be working with the social scientists, the psychologists. They'll advise you on how to do things so that people are more acceptable of them. The first computers looked like machines that were probably going to kill you, right? So people didn't want to use them. But when you got consultants in, psychologists, etc., you started getting this thing with the screen. It looked like a TV. People were more acceptable of it. And so now we all have computers, right? So it takes time, usually for an innovation to move into an environment. And then the last
1 minute, Prof.
Thank you. The last thing to speak about is artificial intelligence and evolution. Now, it's not evolution in the sense, it's evolution in how computers are actually helping us to live better lives. And all of that is underpinned by mathematics and a field of mathematics called optimization. And if you are good at mathematics, right, especially at school, the ideas here are easy to grasp. The maths is not easy, but the idea of what you're trying to do is much easier to get a hold of, and for you to then start thinking about how to use those ideas, especially in your environment, at your school, at your university one day, in your own home one day, right? How do you use these technologies to help you to evolve, to become a better person, a better citizen, a better contributor to society, right? And all of this is underpinned by a knowledge of mathematics that essentially drives this problem solving that we need to be able to do all of this. That's my brief talk, just to highlight a few areas, and just to say to you, that's it. So thank you very much. If there's any questions, I'm not sure if we have time for questions, but I'm happy to take them.
Thank you, Prof. We will take one question. So the question is for the funding that you mentioned. Is the funding is it only for undergraduate or rather university students, or does it also include high school learners?
So the funding is for university learners from what's called postgraduate. So it's after graduating. That's from the National Research Foundation. Funding in undergraduate, there's various funding organizations you apply to. If your parents or guardians are earning below a certain threshold, you can apply to the government for funding for your undergraduate studies. When it gets to high school, there you generally have to look to companies, Eskom, Telkom. Some companies do fund students in high school, but it just depends. Normally, the funding would kick in at university. So if you're going to do engineering, engineering's got a lot of mathematics in it. You would need to look at Eskom, Telkom, etc. If you want to do a BSc, you look at the computing companies, if that's what you're interested in. If you want to do chemistry, physics, there are companies in those areas who can provide funding for you. Any university that you apply to will have a funding office or a scholarships office, and they'll be able to help you. Essentially, they'll give you a list of companies to apply to, or they'll even help to apply on your behalf. Okay.
Thank you, Prof. Thank you so much for that intriguing talk. I think I like how you also mentioned that mathematics, finance also requires mathematics. I think learners need to understand that to be an accountant, you kind of have to practice your maths and have solid math skills. Thank you so much, Prof.
Good. Thank you. Thank you very much.
Sorry, Prof. I would like to now introduce our next. He's not a speaker, but he's going to help us play a little game. So this is your time to now show off your math skills and also stand the chance to win really cool prizes. So with us to play this quiz is Dr. Andrew Craig. So Dr. Andrew Craig is also lecturer at the university. So he's from Makhanda in the Eastern Cape. He studied mathematics and chemistry at Rhodes University. He then went over to Oxford University in the United Kingdom, where he completed his PhD in mathematics. After returning from Oxford, he has since been working at the University of Johannesburg, and his research interest is in lattice theory, which is a branch of pure mathematics that also can be applied to theoretical computer science. Dr. Craig, shall we play the quiz? Rather, shall we take the quiz?
Yeah, let's get going. I just need Prof. Momonia to unshare his screen, and then we can get started. Can someone, yeah, perfect, thank you. Okay, so this is just a bit of fun, nothing too serious. I think the questions are all, they should all be doable, and we hope that you will enjoy it. And there are prizes up for grabs, so you obviously want to do as well as possible. Just here on the instructions, you'll see, in the next step, you're going to be asked to enter your name. Please enter your grade first, followed by your name, so that we know who is winning prizes in which category. That'll be very useful for us. And with all the questions, the faster you put in your answer, the more points you get. So you want to be quick. but you don't want to rush and get it wrong. So that's what we are aiming for, is to see if you can get things right, but also get them right fast. So you need to go to ahaslides.com /UJIDM1, because this is quiz 1, and then we will have quiz 2 in a little bit. I'm seeing the numbers ticking up, so I'm just going to wait a second before we start. It's good. We've got 174 people ready to go. So if you can come first out of 174, that will be pretty impressive. Okay, we're up to 180. I'll just give it another minute or two. And then when you're doing the quiz, you can just focus on your phone. All the questions will be there. Some of them are multiple choice questions, and some of them you need to enter an answer. Just going to give it a little bit longer. I see people are still signing in. And okay, yeah, 220. So people still joining, so we'll just wait another few seconds. And I should mention that there are actually spot prizes up for grabs as well. So even if you don't come first in your category, just by playing the game, you are still eligible for a prize. Okay, I'm going to move on to the next screen, and you will then be required to enter your name, and then we will get started with this first little quiz. Okay, please remember to put your grade before your name to help us track you afterwards. You can see everyone's joining in here. Okay, this is brilliant. Lovely to see so many participants. Okay, so just please remember, put your grade followed by your name. If you're a student, then you want to use 13 for your grade. If you're an undergraduate or postgraduate student, otherwise you just put whatever your grade is. I see we've got a grade 6 competing here. That's brilliant. Kamogelo, that's great. Okay, I think looks like we've got still seeing a few people joining. Sorry for the wait, but it's the most important thing here is to get as many people participating as possible, and to go up against one another. Okay, so as I said, the quicker you answer the questions, the more points you're going to score, and obviously you need to get the question right to get any points at all. Okay, I think we are going to get started now. Here we go. So you can just look at your phone, you'll see the questions there, and okay, time is almost up for this first question. Okay, brilliant. So that foxed a couple of you. The correct answer there was number E, that pi remains unaffected because pi is a constant. Okay, next up. Okay, clock is ticking. Have you found the prime number? We'll see in a moment who gets it. Okay, quite a few there. 33 people getting it correct. Well done. On to the next one. You might need a pen and paper handy, but otherwise you should be able to just reason from what you see on the screen. Here we go.
So, and I'm going to quickly read the question for some of those who are struggling to read it. There is a coin hidden in one of the boxes. The labels provide clues. 2 of the labels are false and 1 is true. Which box has the coin inside? A, the coin is not in here. B, the coin is in A. C, the coin is not in here.
Okay, time is almost up here. Okay, so the correct answer was C there. Moving on to the next question. So this is question 4 of 5.
How many positive factors does 72 have?
Okay, have you got all of those factors? Make sure that you haven't missed any. A few seconds remaining. Okay, and well done. So there were 12 factors of 72. And now on to the last question.
Okay, last question. Consider 3 consecutive natural numbers. Which one of the following statement is not always true? A, at least one number is even. B, at least one number is odd. C, exactly one number is divisible by 3. D, one number is divisible by 6. And E, the product is divisible by 6. So which one of these is not always true?
Okay, so the correct answer there was number D, and now we can see who was the final winner. Okay, so Shiva Singh is the overall winner, but don't forget that there are winners in each category for the grade 8 and 9, and then also for the grade 10 to 12, and there are some spot prizes. So we will be announcing those winners at the end, but well done to Shiva Singh for winning overall there. Thanks very much for playing. There'll be another quiz later in the program.
Thank you, Dr. Craig. Well done, Shivra. Well done to all of you who also tried. There is another game, so get ready for that. Next up is our next speaker, who is Mr. Faisal Mohammed. Mr. Faisal Mohammed has been with Statistics South Africa for over 15 years. He comes from a background of dealing with large amounts of data and has been communicating statistical outputs since he started working for Statistics South Africa. He trained as a marketer with a BCom honors and supplemented with a master's degree in urban and regional planning development, both from Stellenbosch University. Mr. Mohammed has a responsibility for positioning Statistics South Africa to increase the use of statistics and promote a statistically literate society. Mr. Mohammed, over to you.
Thank you very much, Dr. Sitole. It's a pleasure to be here, and I really look forward to welcoming you and giving you a bit of background on maths and stats and how they all join together. And I promise you, there'll be no statistical questions. Those mathematical questions got me thinking, but there'll be no statistical questions in this, although math is a really good foundation for that as well. So as we talk, let's just quickly get into what StatSA is and what we do. We go out and collect information. We go out usually with surveys and censuses. Somebody in green, like I'm wearing today, would come and knock on your door and say, hey, can you please answer these questions? We need it for understanding the development of our country. We need it for understanding what's happening, future planning, decision-making, all those type of things. And that's where StatSA plays in, that type of role. And statistics has a really good and close association with mathematics. So we need mathematical students. We need maths to be coming out, doing maths, getting a lot more mathematics. And I'm going to tell you why as well it's important, not only for us as a statistical organization, but also for us as a country. So now, as I mentioned, people are walking out in green and going collecting information. We're currently running the census where we're looking at everybody's detail and we're asking them a whole range of questions about their household. And in the past, we did this with pen and paper. And we went out, we asked your questions, a lot of information went that way with paper, a lot of information was scanned in. Now we go digital. It's a step in the direction of the fourth industrial revolution. It's a step in the direction of saying we don't need to do a lot of things to get that same information. But then COVID hit, and COVID said, well, you know, you need to think even more than just replacing paper with digital tools such as tablets and so forth. And one of those things that we looked at was saying, how do we then use statistics and bring in that information? And now virtually everyone that's participating in the talk has one of those tools, their cell phone. We can now track and look at tracking people for migration using cell phones. We can look at every time you go and purchase something and you hear that beep beep of the scanner. We look at that and say, well, let's look at changes in pricing instead of asking somebody to go out and measure the pricing and so forth. We can look at satellite images to see where new urban areas are spreading and where they're not. Professor Momiat actually mentioned things where we're talking about how all this plays out. He mentioned real world applications, and there it is. Real world applications of taking mathematics, extending those problem solving capabilities, as Prof. Kirsten was talking about, extending those problem solving capabilities into all these new areas. And obviously, we want more and more people to join and do mathematics so that you can get into those worlds and possibly become a statistician. You heard I come from a marketing background, but it's not too far and too difficult to say, how do we apply all those skills that we learn in mathematics to an organization like Statistics South Africa, for example? So when, let me take a step back. Let me go a little bit backwards and talk a bit about mathematics and our organization. So in 2009, we ran a study or a survey, thousands of kids, over 700,000 learners, to go out there and say, what is your favorite subject? This was part of our census in 2011. And obviously we're running the latest one now, but we went out there and asked thousands of kids, what is your favorite subject? What do you like the most? And surprise, surprise, or shouldn't be if you actually hear, mathematics was their favorite from grade 3 to 7. Favorite subject, hands down, no competition. And then something happens in high school. All of a sudden, languages takes over, maths drops quite dramatically, and you see the other subjects going on there. So the question is, kids come in with a love of maths. They come in, it's built in, it's there. I want to work with numbers. I see the world in numbers, and they play with those numbers. It's fun. And when you get to the high school, things get harder, but it shouldn't stop. If you are good at sport and you get really good at sport, you don't lose the love for sport. It gets harder, more competition, but what goes on? It's not a question that's easy to answer. And there's a variety of factors that lead to that. But if you hear, you're one of those that are possibly, I loved it in primary school, I'm still thinking about it now, and I'm doing it further. And we're here to encourage you and say, yes, those are good decisions to make, and we'll tell you why. But StatsSA also is one of those organizations that realize, no. We need more mathematical people coming through the ranks. We need more mathematical students going from the early grades all the way to postgraduate, because we need them as statisticians. We need them as official statisticians. We need those problem-solving skills to kind of work within our organization. So we went out there and did things in schools. Fun things like we went soccer for stats, and we teach kids about geometry and mathematics. We first go out into the play area. We do things. They'll see the triangles. They'll see the geometry. We go back to the classroom and say, okay, let's take that in. What mathematics did you do out there? Did you ever think about it when you're playing soccer that, there's a lot of maths going on here? And we show them. And then kids aren't like, no, maths is not for me. I'm playing. I'm having fun. Maybe maths. We went to the teachers and told teachers, listen, mathematics, statistics, there's a lot of it there. And we know in South Africa, we have a history and a situation where not that many kids are taking maths all the way. And so what do? We go out there and say, let's help the teachers. Let's help the students. Let's make sure that we can create a population that is enthusiastic about statistics. So that when we go out as an organization and tell you the GDP is X and so many population, and this is the growth trajectory, we have a nation that understands those numbers and a nation that can use those numbers for their own businesses, for their own lives, to make their own decisions, better decisions. But I mentioned the history. Going all the way back to 1953, this is the legacy we have to deal with. And when we had Hendrik Verwoerd, what is the use of teaching a Bantu child mathematics when he cannot use it in practice? This is the legacy we deal with today. This is the legacy you are overcoming by being here, by studying maths, by telling that legacy, no, you don't write my story. I write a different story. This is the legacy that we want to overcome. But this legacy sits with us today. It sits with us when we look at our figures for employment. Look at these figures. This chart here quickly tells you how many people are employed, how many are unemployed, and how many are discouraged. So you can see we have 14 million people employed, 14 million, 7.6 million unemployed. Those are people that have looked for work, couldn't find it. I'm looking, I can't find it. We go out there and ask, are you employed or unemployed? No, I'm unemployed. Okay. Are you looking for work? Yes, I'm actively looking. Then you have close to 4 million people in this country of 60 million odd. 4 million people are saying, I want a job, but I'm not looking anymore. There's no skills. The work environment doesn't meet my skills. The work environment it's too expensive to look. It costs money to look. And there's simply no jobs available. They are discouraged. So we don't count them in the official unemployment rate. They're in the expanded unemployment rate. We don't count them there. So the official rate stands at 34.9%, almost 35%. And then you have another 4 million people who would take up a job if it was there. But they're discouraged. They've lost hope. Don't be one of those who lose hope in the future. Now, a lot of the talk here today has been about the fourth industrial revolution. Look at where the vulnerable is. We have 14 million people and 30% of them are in vulnerable positions, elementary positions, domestic work, elementary. However, it is the parents of many, many of these people who actually will send their kids out and say, no, you go further. And we know, statistics tells us, our publications tell us that it's easier if your parents had higher levels of education for you to get higher levels of education. If they had tertiary, you chances they had tertiary. But our country isn't like that. Our country has a situation where many, many parents never got a chance to go further. You saw that, 1953, you saw. So what happens is you go from elementary and you get into an elementary job. And we want to say, we're looking at the fourth industrial revolution. We're looking at robotics changing things. We need you to make a change to say, don't be in vulnerable positions. Go further, look further, see what can be done. And as a graduate, your chances out the box are so much better. As a mathematics graduate, as any graduate, we look at higher education. your chances of being employed in South Africa are much better. Unemployment rate of 12.5% versus the national average of 34.9. If you don't have matric, it's 40.2. Those numbers tell the story of our country, but it also tells the story of further education. Education pays, education pays, education pays. We can see it in the numbers. We see it in all our numbers that we show. Education pays. And by learning further, you get there. I recall another saying by the late Prof. Kambule, who said, be like a giraffe. Eat from the top leaves of the tree. There's no competition there. You can be like that. You study further. You study what could be considered hard, but it just takes application. What could be considered hard just takes application. Study further, go further, and you will eat where there's no competition. These are the things we're looking at. Our country is changing. You would think places like manufacturing took huge amounts of semi-skilled and unskilled labor. Look at how that's dropping. What's replacing it? Financial services, business services, insurances, modeling. People using their minds to create creativity and logic to create businesses that actually make a lot of money and that drives the economy. We can see it here. Where's the money? Finance. This is our economy. This is our economy in a little square. And that says, where is the economy headed? Financial services. Manufacturing has declined over time. We are in a service economy. We are doing things virtually, paying virtual services. So that's where things are happening. This is a quick presentation, but want to say that we know that people have come from a history where it's been difficult to do mathematics, where we can see the issues. We know that you can overcome it, and we know that when you overcome it, statistics tells us, the numbers that are reflected in our country tell us, you will achieve, you will get better. Your chances are much better than those who don't take that further step on. That tells us, brings us back now, I'm just going full circle and saying, as people who study mathematics, it's a springboard into statistical careers. But statistical careers also don't have to have the word statistics in them. They could be researchers, data analysts, software engineers, risk analysis, many, many things where it doesn't have the word mathematician, doesn't have the word statistician, but uses the skills of both mathematics and statistics. And so we want to be here and say, utilize those skills you have, go further, make a difference. And from that, I want to say thank you very much.
Thank you very much for your presentation, Faisal. It was very enlightening. And I was also quite fascinated to see that the numbers actually show you that furthering your education is actually assisting with decreasing unemployment. So I don't think we have any questions from the audience. I will just double check. Do we have any questions from the audience for our speaker, Faisal Mohammed? And no. Since, okay, Lungi, you can go ahead. Is there a question?
No questions.
Then I'd like to thank our speaker, Faisal Mohammed. We truly appreciate you joining our program and presenting and interacting with the students.
Thank you very much.
I would now like to tell you more about our next speaker. Our next speaker is Dr. Mamoletsi Mosia, and she is the Managing Director at the South African Agency for Science and Technology Advancement, SAASTA. Mamoletsi earned her BSc Honours degree and MSc in Chemistry from the University of Natal. She also obtained an MCom degree in Leadership Studies and her PhD in Chemistry from the Technical University of Eindhoven. Having recently joined the NRF, she also has experience in working at the CSIR as a senior manager, as well as, prior to that, she was a scientist at SASL, where she grew within the ranks to principal scientist level. I'm quite excited to introduce you to Dr. Mamoletsi Mosia from the NRF SAASTA. Over to you.
Thank you for the kind introduction. I was listening to Faisal and looking at his presentation. I'm like, yo, this is a setup how am I going to match this? Because me, I'm just going to talk to the audience, and I don't have all of these brilliant stats that he was presenting. But as I was listening to him, I was reminded of almost, 20 years ago, 18 years ago, when I completed my PhD. And as part of showing that we are not only into science, but we understand what's happening into the world, we needed to present 5 sayings about just the statements that just made sense to you and that made impact into your life. And at the time, I wrote something about what he just presented about Bantu education. And I said that the architects of Bantu education, they wanted us Black people to only end up as maids and gardeners. And as a parting shot to that statement, I said, I think it was I said, today it's 2004, look at me now. And at the time I was graduating with my PhD in a university in Holland. And I think I'm saying this just so that any Black child who is sitting here today would realize, or at least can see, that even though the architect of Bantu education, and yes, we are still suffering the legacy of Bantu education even today, even though the architects of Bantu education did not want to see us where we are today, I am glad to see so many Lungiles and Azwindinis are sitting here today, because then it means that they have reversed that which the Bantu education architects wanted to achieve. But I'm digressing. I was just excited to listen to Faisal's presentation. I am from the National Research Foundation. In particular, I'm from the business unit that is responsible for the advancement of science and technology. Now, you cannot have science and technology without mathematics. We cannot advance science and technology without advancing mathematics. And that's the reason why today we are here and we are celebrating the international. I am not going to talk of the statistics because Faisal has already done that. I think for me, it's just to inform you of what we are doing as SAASTA. We very much involved in the education sector, in that we run Olympiads, and we part of the organizations, and we support the organizations that run Olympiads, such as the Maths Olympiad, the Science Olympiads, all of these Olympiads that are meant to increase the interest of the STEMI with the learners. We also run, or we are pushing, for lack of a better word, the after-school science clubs. And by doing that, we're not only pushing the love of science, but we are pushing everything science. And as I said earlier, you cannot have science without mathematics. So we want to engage the learners in all the activities that enable them to develop the love for science and to develop the love for mathematics, and to be in spaces where they are able to work with each other and assist each other in solving the problems that they find at school. And the most important thing, and that ties up to what I said earlier, is that we provide role models. So every time we go to schools, we take young people who are the same as the children that we want to engage with, to go and say, I'm from Nkandla, I'm from Vuwani, and look at me, I'm now a statistician. Look at me, I'm a geologist. Look at me, I'm a mining engineer. So that these children, even though in their families, they don't see these people, or they don't get to see these people, but by us exposing them, they are able to see themselves in these people, and they're able to dream and say, if she can do it, I can do it too. But we don't only end it there. Once you get to university, we also, we allow others to help you to get your undergraduate degree. But once you get up there, we then, at honors level and going upwards, we then, as NRF now, not only as SAASTA, but as NRF, we then provide you with the finances to go further with your studies. As a country, we're not doing very well with regards to the people who have masters and PhDs, especially in the STEM field. And as NRF, we want to actually change that picture and make sure that we have more and more Black people and females in general who have PhDs in the STEM fields. And basically, that's what the NRF is for, and that's what SAASTA is for. SAASTA, I always tell people that without SAASTA, NRF will struggle to find people. So we as SAASTA, we make sure that we feed the system with the people in the STEM fields by making sure that they are interested in math and science. And we're trying also to ensure that the drop in an uptake of pure maths decreases, because now you see in our high schools, a lot of the children are so afraid of mathematics and they're doing mathematics literacy. It could be because the educators are not as skilled in terms of making sure that the learners pass, and that's where we also come in educator upskilling and just getting them to teach mathematics better. So it's a suite of things that we're doing, but more than anything, we want to make sure that we increase the number of STEM graduates in the country. And I'm almost done. Thank you so much. So more than anything, the aim is for us to increase the number of STEM graduates in the country, and to also transform the face of a STEM employee in the country. And so both NRF and SAASTA, that's what we are here for. You can find more information at www.nrf.ac.za. And thank you for the opportunity, and enjoy the day. Happy International Day of Mathematics.
Thank you, Dr. Mosia. That was really great. Thank you so much for your message from NRF SAASTA. That's Dr. Mosia. Our next speaker is Dr. Wilmarie Morton. So Dr. Wilmarie Morton completed her undergrad and honors at UJ, which was at the time called Rand Afrikaans Universiteit. She then moved on and did her MSc and PhD at Wits University in algebraic logic. So from then on, she started working in the Department of Mathematics and Applied Mathematics at the University of Johannesburg, and has 15 years experience in tertiary education. Dr. Morton, the floor is yours.
Thank you very much, and thank you for the introduction. So if I can just confirm that you can see that you see what I've shared. Is it full screen? Can you all see it?
Yes, yes, thank you.
Right, so I have a slightly different type of talk to the talks that we have had so far. I thought to kind of just look at something every day and just to kind of see what the mathematics behind it is. So something that most of us encounter every day when we go to a shop is something like either called a universal product code or a European article number. And obviously, if we buy books, we've got the ISBNs. And the question is there any mathematics in there, right? So obviously, there's some very standard mathematics in the sense that it's a code. So we take these numbers that are at the bottom there and we encode them into binary. So that's a bit of mathematics. If we look at this, just to get the barcode, there's some smart design here. So for instance, these parts that I've highlighted here, those are called the guards. And it's essentially so that when your scanner scans this particular barcode, it kind of knows where to start, where the middle of this is and where the end of this is. And then the numbers get encoded in between these guards. And this is done in a very smart way. So if we look at this here at the bottom, you'll see I go 10, 10, 10, but the left and the right don't look the same. And that's intentional, right? So that whatever is between these first two guards, that encoding is different from the encoding between the next two. And that's just so that it's so that the scanner can, or the computer rather, can determine where to start with these numbers. But that seems like very far down for the mathematics. So where is the mathematics then in this? The mathematics that I want to point out today is the check digit. So in an EIN or an ISBN, you typically have 13 numbers, and the last number there is a special digit. And there's some mathematics behind finding that particular digit. So let's see if we can see what is the idea here? So the idea is that if this code is typed in and an error is made, can we kind of pick that up, or will the computer just kind of accept whatever you type in? Or if you scan and maybe the barcode is slightly damaged, is there a way for the computer to pick up that something's wrong and that's not really the code that you're wanting to scan, or will it kind of just happily go on? So that's the purpose of this check digit, to make sure that once you've entered a number or you scanned in a number, you realize that there's a problem if you find a problem. Right, so what can we do? How can we add one symbol there at the end to check? So one thing we could do is we could just add up all the other 12 or 9, however many symbols you're using for your particular code, add them all together and divide by 10. So why are we dividing by 10? Because if we divide by 10, then we will have a remainder from 0 to 9. So either it's something like 20 and it's divisible by 10, or it's not divisible by 10 and you have a remainder of 1, 2, 3, all the way up to 9. And so that's then what we could potentially add as this check digit. Would that be good enough? Let's ask these questions. So maybe just to illustrate first, so suppose this here's the number that we want, then what I mean by that is we literally just add all of these numbers. And so for instance, here we get to 23, and we see that 23 is 2 times 10, and so then the remainder there is 3. And so then we would be tempted then, if that was the number that we were trying to add a check digit to, then we'd add the 3. So the question is, well, will this always pick up a problem? Right? If I type in the wrong number, or let's say something went wrong with that barcode and something looks light and it's supposed to be dark, and so now it enters the wrong number, will it pick it up? Well, yes, if you just have the single digit that's wrong, it certainly would pick up if something was wrong there, because, I mean, because we're doing division by 10 and we're only using these digits from 0 to 9, yes, it would pick up that. But what if we swap two numbers? So somebody trying to scan this barcode, you can't do it, and the person has to type it in, and instead of typing in 1, 2, they type into 1. Will it pick that up? No, it won't, right? Because whether you're 1 plus 6 or 6 plus 1, it doesn't matter. Addition is commutative, we say, right? So the order in which we do that addition, it doesn't matter. Right, so yeah, we say no. It seems like this is not a good enough option. So what did we do, or what was the solution then to this problem instead? The idea was to go and find a weighted sum. So what does weighted sum mean? It means we're still going to add these numbers together, but not as they are. We're going to give a weight to each number. So we're going to multiply it with some integer. And then in that way, you would be able to see if you swapped two numbers, because now the weight for one position is different from the weight for another position. So this was obviously first implemented in the ISBN 10 codes. So there are two examples there of ISBN 10 codes. So let's see how we would go and find the check digit here. So what they decided is they would start with weights from 10 down to 1. So an ISBN 10 code has these 10 numbers. And if you go from left to right here, you'll have the weight 10 for the first digit, then the weight 9 for the next, 8, all the way down. And then your check digit is actually just got a weighting of 1. But for now, we're just going to look at the part that goes from the 0 to the 2, right? So now we're just looking at the parts where we have a weight of 10 all the way up to a weight of 2. Right, so what do we do there? Because we want to confirm that this 1 should actually be the check digit. So now we're going to take each of these digits and multiply them with the various weights. So like we said, 0 times 10 and 2 times 9. And so we go on up to the point where we get to this weight of 2 for the last or second to last digit 2. Right, once we've done that, then we add all of this together. Right, so we've got the 18, 17, 30, we get to 89. And the goal here is to choose a check digit that will make the sum if you were to go and add this last term, so weigh that with 1, so that if you go and take the full sum, then you get something that is divisible by 10. So now here we've got 89, right? And clearly that's not divisible. Well, sorry, my apologies. For the ISBN 10, they didn't actually use the number 10, they used the number 11. Sorry, that's kind of a crucial point there. So the goal was to choose a check digit that would make this number divisible by 11. Now, here we would need another 1 to be able to say that this is divisible by 11. So basically, we do the division by 11, we find the remainder, and then as long as that remainder is not 0, then we find out what do we need to add to be able to make this sum ultimately divisible by 11. So if it's 0, then your check digit would just be 0. But if you got something other than 0, so like here we got 10, then we go and say 11 minus 10, it means I need to add another 1. So my check digit here just needs to be 1. Right, so ISBN 10 codes, they did use the weights, all the weights from 10 down to 1 essentially, and they did division by 11. Now, what happens here, you may, in some older books where they still do use the ISBN 10 codes, you might see an X and be a bit confused. Well, remember that here we were using division by 11. And the problem is that we only have 10 digits, right? So we only have from 0 to 9. So if we find ourselves in a situation where the remainder after division by 11 is 1, then the thing that we need to add to change the sum to become divisible by 11 is actually 10. But that's 2 digits, right? And the whole point here is to add as little information as you can so that you don't kind of belabor the amount of information that needs to be stored. And so how do we kind of get around that? Well, what they did is they used a capital X because that was the Roman numeral number for 10. But in a sense, to add an additional symbol here, that is not ideal. And so since the ISBN 10, we've kind of adopted a different way. So we can ask a couple of questions. Why did they choose to use 11? And what if we don't want to have this additional symbol of X for 10? Because that does complicate matters a bit. And why can't we just go back to that first option that we had where we said division by 10? We still use weights, but we do division by 10. So let's have a look and see why is it that 11 worked so well? Well, it worked well because it's what we call a prime number. So a number, a natural number greater than 1, so from 2 onwards, is called a prime number if it's only positive integer divisors are 1 and 11. So if you look at 2, 2 is a prime number because it can only be divided by 1 and 2. And that's in fact the only even prime number that we can find. And then from there on, 3 would be a prime number, 5 would be a prime number, and 11, this example that we're using here, that's a prime number again. Now, why is that important? Well, it's important because all of these weights that we used from 10 all the way up to, well, 2 and to 1 really, they are what we call relatively prime to the number 11. So what does that mean? That means if you look at their common divisors, the only thing that they have in common is 1. So what does that mean? What do we need to do then when we go and think about using 10? We need to think about using only numbers that are relatively prime to 10. So 5 is an example of something that's not relatively prime to 10 because obviously 5 is a divisor of itself and it's a divisor of 10. And what could happen if we use something that's not a divisor? So I'll show both of these. I'm slightly concerned that I'm running out of time. So if we look at these two numbers, notice here that I've got the 142 and I've got the 146. And now I'm saying, let's suppose for this first position, we have the weight of 1. For the second position, we have the weight of 3. And then for the last position, we use a weight of 5. So if we go and do that, so we take those products and sum them all together, then what we would use as the check digit for both of these would be the 7. So if we made that error from 2 to 6, we wouldn't be able to pick that up. And that is basically because 2 times 5, 4 times 5, 6 times 5, basically any even numbered multiple of 5 will get you to a multiple of 10, right? And so then you won't be able to distinguish, or it won't provide a different remainder after 10. So then what we get from that is that, yes, we can go and do division by 10 rather, but what we want to do is we want to go and use only weights that are relatively prime to this number that we're doing, that we are dividing by. So good candidates would be 1, 3, 7, and 9. And so in these codes that we see every day, what they do is they make use of weights of 1 and 3, and so they alternate between them. Confusingly, the ISB 13 and the EAN don't do exactly the same, in the sense that the one gives the weights of 1s to the odd numbers and the weights of 3s to the even numbers, and the other one does it the other way around. But let's go and have a look at just one European article number, where we go and find out what should this error check number be. So what happens here is so what they say here is they don't start numbering from the check digit, but from the one just to its left. So that's where you should start. So we're starting to number from the right here. We say that's position 1. So then 1 is in position 2, 0 is in position 3, etc. And now what we're going to do is we are going to take all of those digits that are in even positions, and we're going to give them a weight of 3. So we multiply each of these with 3. And all of those digits that are in odd positions, so starting with the 6 and then the 0 and another 0, and then the 7, etc. And for those, we just give a weight of 1. And if we then take these, the sum of these, then we get to some number. Again, we do the division by 10, and we say, what would I need to add to the sum so that it would be divisible by 10? So basically say 10 minus the remainder, that gives me a 9. And that's then why this check digit here is a 9. And this process picks up whenever you make a single digit error. So if there's a 1 and you accidentally type in a 2, it will pick that up. And for the most part, it will pick up when you accidentally swap numbers. So let's say instead of typing in 1, 2, you type in
1 minute,
1.
Dr. Morton.
Thank you very much. It will also pick up that, right? But it won't pick up all of them. And that is basically just for the following reason, so that whenever you have numbers that differ, so digits that differ with 5 from each other, then what's going to happen there is you're going to just have an additional 10 more, right? Because you have that 2 times 5 that acts in there. And so you won't pick up that there's a difference in the value in that sense. What could be better than knowing something is wrong when something is wrong, right? Lots of things could be better, in particular, something that fixes the problem, right? So initially when I was asked to give a talk, I wanted to chat to you about not just the check digits, but also the error correcting in QR codes. But for that, I needed to be able to tell you what Galois fields are and all sorts of things, and 10 minutes are just not enough. But what's interesting here is in a QR code, something that you're familiar with, that many of you often use, we don't just have a way of showing that something's wrong. There's actually embedded in this, so half the information almost in a QR code is essentially information that helps you retrieve the actual information that you wanted. And that's why I could go and create a QR code like this, where I have our logo in front of a part of the code, because embedded in the QR code is enough information to retrieve what was actually supposed to be the data in there. And so if you are interested in that, there is quite a lot of nice mathematics behind the encoding for QR codes. Thank you for your time.
Thank you, Dr. Morton. I just want to check. No, I don't think we have any questions for you. Thank you so much for that. very interesting bar coding mathematics that we had there. Before I move on, I think next we have the quiz. Yes, we do have the quiz again with Dr. Craig. So get ready to, Dr. Craig, are you ready for the next quiz?
Yeah, I'm ready. I'm sharing the quiz now. And so we'll just, as before, again, this one is a little bit harder. So you're definitely going to want to have a pen and paper ready because there are a couple of questions that will require some small calculations. But once again, it's mostly about sort of logic and reasoning, which is really what maths is all about. It's about solving problems. So the link is in the chat as well. I'm just going to wait again, just wait a minute or two for people to join. I'd just like to mention as well, I know people are posting some links to various sort of interesting maths topics in the chat. There's a really good YouTube channel called Numberphile. It does, it covers topics quite similar to Dr. Morton's talk now, where it looks at mathematics behind sort of everyday concepts. And there's some really brilliant videos. It's all relaxed. It's just people chatting, talking you through it. But you can learn a lot of quite deep mathematics from the Numberphile YouTube channel. Okay, so the numbers are ticking up here. As I said just now, you want to have a pen and paper ready. I will read out the questions. I know some people were struggling in the last one to see the questions, so I'll read them out. And also, I'm going to put in the chat after this quiz, I'm going to put a PDF which will have all of the questions, question by question, and then it will have the answer as well. So you can, if for some reason your network bombed out and you didn't get to do the chat online, you can download that PDF and go through the questions one by one and check your answers against the answers given there. I think it's a fun thing to do. It's kind of how mathematicians like to spend their weekends solving problems. So I hope you'll join us and do the same. Okay, we've got pretty good numbers here, so I'm just going to go on to the next slide. So this is where you are going to add your names. Yeah, so we've got people coming in. Remember to include the number that represents your grade to make you eligible for prizes. So if I can just ask one of my co-hosts to post the link again in the chat. It's ahaslides.com/UJIDM2, because we're on to quiz 2 now. And yeah, then just remember that when you join, please put a number in your name so that we know what grade you represent, and definitely have a pen and paper ready. There are going to be some questions that require a little bit of calculation here. Okay, I'm going to give it one more minute and then we will start. Nice to see lots of people joining. And again, if you do happen to miss out, don't worry, the questions will be in the chat afterwards and you can go through them on your own or with a friend, maybe challenge some of your friends at school, siblings, and you can have a little quiz off next week when you see your friends or over the weekend. Okay, we are going to start. Good luck, everyone, and let's see who gets the prizes. So the first question asks, what is the minimum number of participants required to attend today's event so that we are certain that at least 2 participants have their birthday in the same month? And the options are 12, 13, 14, 24, or 365. Cool, okay, so a couple of you were foxed there. So we only need 13 people to guarantee that 2 people have their birthday in the same month. That's called the pigeonhole principle. Question 2 coming up. It's going to be a hard one to read out. We've got a picture. It has in the bottom row, there are 4 boxes, 3, 4, X, and 6. In the second row, there are 3 boxes, 7, blank, blank. Then 2 boxes, 2 blanks, and the top box has 48. And you are asked, you're told that the 7 is obtained by adding the 2 numbers directly below it, and the rest of the numbers are obtained in the same way, and it's asking you to solve for the X in the bottom row. Okay, 15 seconds to go. Let's see who can crack this one. Okay, time's up. Let's see. Brilliant. So 9 was the correct answer, and 15 of you got that. Brilliant. Well done. Okay, question 3 coming up. So question 3 says, after 4 games of the World Cup, the women's Proteas have scored an average of 223.75 runs per game. So that's after 4 games, they have scored 223.75 runs, an average of that number of runs per game. The question is, how many runs would they need to score in their 5th game in order to have an average of 230 runs per game after 5 games? In case you haven't been following, the women's Proteas won their first 4 matches at the World Cup, so it's all looking pretty good for them. So after 4 games, an average of 223.75. The question is, what do they need to score in their 5th game to average 230? Okay, less than 10 seconds. Okay, brilliant. Another 15 students got it correct. The answer was 255 runs that they needed in their last game. Okay, question 4. So we are told that x plus y is equal to 5, and x squared minus y squared is equal to 10. So x plus y is equal to 5, and x squared minus y squared is equal to 10, and you are asked to find the value of x minus y. So a little bit of algebra here. 15 seconds to go. Okay, let's see who got that one. Nice, 32 of you got it correct. The answer there was 2. Moving on, question 5. So here the question says, we have 2a is equal to 3b, which is also equal to 5c. So 2a equals 3b equals 5c. All the numbers are positive, and then it's asking you to find the relationship between them. The first option is a less than b less than c. The next option is a less than c less than b, c less than b less than a, c less than a less than b, and the last option is b less than c less than a. Let's see who got it. Okay, well done. good performance there in this question, 48 of you getting it right. And now on to the last question. Question 6 of 6 to determine our winner. Let's see who can pull it out of the bag. The question says, on a farm, there are some sheep and ducks. In total, there are 40 heads and 124 legs. So there are sheep and ducks. There are 40 heads and 124 legs. And the question is, how many ducks are there? Ten seconds left. Okay, the correct answer there was 18 ducks. So well done to the 4 participants who got that correct. And now let's see who our overall winner is. Brilliant. So well done to Ntokozo Mthembu, the winner of this second quiz. Remember that there are prizes in each category, and there are also spot prizes. So hopefully you're still in line to win a prize, and well done again to Ntokozo Mthembu. Thanks very much.
Thank you, Dr. Craig. Well done, Ntokozo. Next up, we have our interviewing a mathematician. So meeting a mathematician and finding out what it is mathematicians do, and how is it that they just always thinking about maths all the time. All right, so to conduct this interview is my co-host, Dr. Serene Ratalal. So she will introduce her interviewee. Serene, over to you.
Thank you, Dr. Sithole. I'm actually really excited about this segment in the program. And that's because this Meet Mathematician series is being launched today, live on this IDM event. And so this is very special to me because this is a series that has been born out of the Mathematical Structures Research Group at NITheCS. And so today, I am very humbled to be able to be on this platform and interview a mathematician. And so more importantly, I'm happy that it's actually live. So today I'm going to be interviewing Professor of Mathematics, Professor Zura Bjanalitsa from Stellenbosch University. I'll just tell you very briefly a bit more about his research interests. His research interest lies within the field of categorical algebra, but more generally or widely, category theory, topology, algebra, and logic. He serves on the editorial board of two of the 3 main international journals in category theory, and is the current president of the South African Mathematical Society. So welcome, Prof. Bjanalitsa. I'm so glad that I'm able to interview you today.
Thank you very much, Serene. Or should I say Dr. Ratalal, because you're actually also a mathematician, right?
Yes, indeed.
Is my background visible correctly?
It is indeed, yes, absolutely perfect. And I thought I'll join in and match you too. So thank you once again, as I said, for joining. And I think what I'd like to do is actually ask the burning question. And that is, what influenced you to become a mathematician? So the burning question is, why did you become a mathematician?
The creative process. I enjoy creating something out of almost nothing. But the process itself is what is very enjoyable, and that kind of enjoyment I couldn't find in any other area, the one that I found in creating mathematics.
So where did your love for mathematics actually begin?
I think, well, my father is a mathematician, so I've been exposed to mathematics a lot, and I learned a lot of mathematics from him from early age on. But then the point where the passion was really sparked was when I was working on a project at the end of school. I had to take a part in a research type of competition throughout the country. I'm from Georgia. And a research project I worked on there, I constructed something which later turned out to be an n-dimensional vector space over a 2-element field. And that was the process which took several weeks. And it was so deep and so enjoyable that I knew from that time on that that's what I want to do for the rest of my life.
I think that's absolutely beautiful. Can you share with the students what it is that you do as a mathematician every day? So what does your tasks on a given day involve?
Well, we are all forced to do things we don't particularly love in everyday life. But when I do have opportunity to do what I really want to do, then that's doing mathematics. And so doing mathematics is a bit different from, for example, what we do at school or even competitions when you have a time limit. Real mathematics begins when you basically forget about time. You don't keep track of time anymore. And you are focused on trying to understand a certain phenomenon. And then you work for hours and hours, but these hours run without you noticing them because you're so much involved and so much love what you're doing. So that's the task that I would describe would be for my perfect day, when I have time to do mathematics all day and maybe sometimes even go into night. Yeah, I would describe that as the day when I want the day to be the way I want it to be. But other times we do other things as well, of course, as everybody else.
Can you share with us perhaps something about one of your mathematical areas of interest, something that makes you happy on your perfect day? What would it be that you would spend time researching?
The area of category theory, it's a branch of mathematics where it's sort of like mathematics of mathematics. You try to understand different phenomenon in different areas of mathematics, but then you also want to connect these phenomenon with similar phenomenon in other areas of mathematics. Looking at some specific mathematical situation, and then you notice some kind of pattern, or maybe some kind of something sparks your emotion, some specific aspect of that situation, and then you go after it and you try to explore where it leads to. And then it's like hiking, where you hike for a long time, and then at some point there is this beautiful view in front of you on the top of the hill that opens up. I think I forgot what the question was.
I just wanted to know a little bit more about what would you be spending time researching on your perfect day?
Yes, so that kind of thing where I take a phenomenon from a specific topic in mathematics, and I try to understand the deeper insight behind it. And then the tools of category theory provide you means for engaging at a deeper level. And then after that, you discover connections with other topics as well that previously you couldn't have predicted that such connections would arise. I cannot be more specific because then we would have to study a lot of mathematics to be more specific.
No, indeed, but it's definitely given us some insight into your process of conducting mathematical research, and I think that's very important. My next question is about the journey to becoming a mathematician. So how did you become a mathematician? What is the educational background that one would require?
I think much more important than educational background is passion, because so we all know that, well, everything requires hard work, right? And including mathematics, but you can't really do hard work if you don't love the thing. So if you don't have strong passion for the subject, you end up minimizing the time you spend with it. And if you only spend the time that you're forced to, perhaps by the school or the university, you will actually not get there. So much more important than education is passion. And education is just like a framework which allows you to express that passion. But sometimes education even could stop you. For example, at school, I must say that I didn't like mathematics at school. In fact, I was doubting that I would actually be interested to do mathematics, because school mathematics for me was very restrictive and very limiting in terms of creativity. So, but then when I worked on that project that I talked about, that I saw what really mathematics is about, that's when I decided, okay, so education at school doesn't define what mathematics is, and I have to find my own mathematics, and each mathematician actually finds their own mathematics. And that journey of finding your own mathematics in the framework, in the educational framework where you are, is, I think, much more important than education itself. But otherwise, the usual education is, of course, you do undergraduate studies, and then you do postgraduate studies, you do PhD, and hopefully after that, you're able to do your own mathematics.
Absolutely. Thank you for sharing that. And I think it's very important what you mentioned. It's about curiosity and finding out and investigating things for yourself as well. So seeing that you've gone through this journey on your own, what else would you recommend an aspiring mathematician to perhaps do in order to make their journey a little bit easier in becoming a mathematician? So is there any advice?
When you ask easier in what sense? Because it's not easy.
Oh, certainly not.
It's actually the other way around. It's very difficult, but then you start to enjoy that difficulty. So the difficulty for you is no longer a difficulty, but it's actually something that sparks your passion and your interest. But then there is also another kind of difficulty, like having a bursary and having a good teacher and so on, these kind of difficulties. And so for that kind of difficulties, what is important is to search, especially to search for other people who share similar passion as you. So for example, it could be your teacher, it could be your school teacher, it could be your friend, it could be someone else. Searching like-minded people, I think, is extremely important, not only at the beginning, but also later on when you're entering into career. You want to be collaborating with other mathematicians who have similar mathematical interests. So that makes life easier when you have found such people. But you don't expect that these people will solve your mathematical problems. So you at the same time, you want to enjoy solving mathematical problems. And so a problem for you shouldn't be a problem anymore. It should be something that excites you.
Exactly. We should be excited by a challenge of being presented with a new problem that will help us discover or learn new things about the unknown.
Yes, but of course, should be is a bad word here. I mean, not everybody will be excited by mathematics. Some will be excited by art, by music, other sciences. So I don't think we should kind of prescribe this as a rule. But I do believe that it's possible to find enjoyment in mathematics, even when your main passion is in something else.
Agreed. Thank you for those sentiments and also for correcting my choice of words. So before we end, do you have any final words that you would like to share with students who would like to pursue a career or the study of mathematics?
I think I would revert back to putting love at the first place, and to be kind of protective of what your heart tells you, because very often you might be in a situation where the environment might be telling you something that goes against your heart. And the important thing there is to persevere. And by searching for like-minded people, then they will then support you to persevere further. So don't abandon the idea that mathematics should be enjoyable. If it is not, it doesn't mean necessarily that something is wrong with your understanding of mathematics. It might be that something is wrong in the system in which you are interacting. and don't be afraid to propose to change the system. I think mathematics is all about discovering new things and making changes. I mean, new things are discovered by the desire to make some change, right? So fighting for what you believe in, that's the kind of attitude you want to have in order to succeed in mathematics.
Thank you, Prof. NITheCS, for those closing sentiments on love and perseverance in the pursuit of mathematics. So
thank you very much.
Thank you. And so as we wrap up this session on Meet a Mathematician, I would also like to announce that this interview will be available on the NITheCS YouTube channel, as well as an interview with Professor Loyiso Nomta, who I had the privilege of interviewing a few days ago. So his Meet a Mathematician interview will be available on the YouTube channel of NITheCS on Tuesday morning. So we look forward to engaging with you online, and I hope that we inspire a future generation of mathematicians through all of these initiatives that we will be running. So stay tuned on the YouTube NITheCS channel for further initiatives. And so that brings us to the end of the Meet a Mathematician segment, and I thank Professor Zurab NITheCS once again.
Thank you. Bye.
So, as we move on in the program, I think we've now reached a point that all of you have been eagerly awaiting, and that is the announcement of the winners of the photo challenge, as well as the quiz winners from the other categories. So to introduce and announce the winners of the photo challenge, I would like to introduce you to the president of the Northcliff Rotary Club, Robert Jacobs. So Robbie is a lover of mathematics since at least 2001. He is a civil engineer by training, and he currently works in corporate risk management and is a person whose love for maths has guided his career path and also enabled his progress both within the working environment and outside of it. I now hand over to the president of the Northcliff Rotary Club, Robert Jacobs. Over to you.
Great, thank you so much, Serene, and thank you to all of the attendees for this wonderful International Day of Mathematics celebration. You know, I'm not a mathematician, but I can certainly see that there are going to be quite a number joining the ranks of Dr. Ratilal, Dr. Zurab, and all of the other speakers that have been here today. So, you know, maybe you're asking, what has Rotary got to do with mathematics? Rotary has focus areas of education and literacy and economic and community development. And thankfully, you know, some of my work has really been done for me today by the previous speakers explaining how vitally important maths is and the other sciences are in community development, specifically the stats essay. I mean, that was really fascinating. And I think that I am definitely with some of the learners today who, yeah, we had a little bit more difficulty in Dr. Craig's quizzes, so that was a lot of fun. Before I get on to the prize winners, which I'm sure you're really excited about, I want to say that, you know, how do you get involved? Just the same as you get involved with your school, with your community, you can get involved with supporting your community through joining your local Rotaract or Interact clubs. That goes right down to high school and university level. So if you are interested, please look on our website, which is northcliffrotary.co.za, and there are a lot of resources that you can get through that. Right, on to the thing that we've all been waiting for. Right, the photo challenge winners. What this really shows to me is that there's people who have been engaging right from the very first, the first notification about the International Day of Mathematics. And so here we are to celebrate them. There are prizes for the runners up, which is UJ merchandise, which is very exciting, especially if you're not quite at UJ yet. It's really exciting. And there are prizes for the winners, which is Take-A-Lot vouchers. And as you know, I'm sure by now, Take-A-Lot, you can pretty much get, you know, anything online today. So let's go. The first is the grade 8 and 9 category, and the runner-up is Ntokoza Nkuna from Kanisa Education Centre. Congratulations, Ntokoza. And the winner for the grade 8 and 9 category is the Boys and Girls Club of SA Mareberg. So well done to all the people in grade 8 and 9 who've entered this competition. Next up, we have the grade 10 to grade 12 category. So this is the guys who are really thinking about, you know, what's coming next for their lives. And the runner-up is Msizi Makatini. And the winner is Gayabu Lukusa. Well done to all of the winners from the grade 10 to 12 category. Finally, we have the undergraduate category. And, you know, this is when things are really getting tough. Things are, you know, you're really spending a lot of time working and studying. So congratulations for being part of this. And the runner-up in this undergraduate category is Nomasande Njobe from NWU Vaal campus. And the winner of the undergraduate category, and I'm glad to see that this person has been engaging with us today, is Tenswalo Ndlovu from UJ. So congrats to all of the winners. You can get your prizes by sending the details to the following email address, and I'll post it in the chat in a moment, cratilal@uj.ac.za. So you can send your full name and surname, your contact number, and your delivery address or email address. So all of those winners, congratulations. Northcliff Rotary is proud to be part of such an initiative by the UJ, and we thank you for spending your time here on this Saturday morning, when I'm sure a lot of you will be very happy to be outside relaxing in the sun. Thank you very much, and back to you, Suri.
Thank you, Mr. Jacobs. Thank you so much. Yes, that's very true. I think a lot of them would be happier going to bed since they had to wake up so early to be part of this event. So we thank them for that. Now, to announce our quiz winners and their prizes is Dr. Sonwabile Mafunda. So Dr. Sonwabile is also a mathematician, currently teaching mathematics at the University of Johannesburg, and his interest is in graph theory. Dr. Mafunda, over to you.
Thank you so much, Dr. Stelle. Okay, I hope I'm audible. Can you guys all hear me?
Yes, we can.
Okay, thank you. Without wasting time, I think this is a moment that we've all been waiting for. So the winners for the first quiz were, for grade 9 and 11, we had James. And from grade 10 to grade 12, we had Shriyash. And from for the universities, which is the undergrad university student, we had Shigra. Okay, congratulations to all of you guys. And at the end of this presentation, I will show an email address that you'll have to email to obtain your prizes. Okay, for the second, for the sport prizes in quiz 1, we've got the following people. From grade 8, we've got Madia Hussein, and from grade 11, we had Katleho, and for the undergraduate, we've had Rachel Mufukeng. Congratulations once again to all of you guys. And for quiz number 2, we had the following people. That's grade 9 and grade 11 winner was Harrison with 277 points. And for grade 10, we had Connie with 377 points. And for the university category, we had Ndogozo Mtembo with 460 points. And well done to you guys. For the sport prizes, we've got Madia from grade 11 again. We've got Kay from grade 12 and Tembelihle for the university category. Well done to all of you guys, and well done to everyone who has participated. Thank you so much to Dr. Craig for running this quiz, to Dr. Robinson for creating the quiz, and the details that you would need to email to claim your prizes are shown in the screen. But I'm sure Dr. Ratilal is going to talk more about that. Thank you for joining, and well done to everyone who participated in the quiz.
Thank you, Dr. Mafunda, for that. I'm sure everyone's excited to have found out who has won. So please note that if you are a winner of Quiz 1, then your prize is actually a wireless charger and a 8,000 milliampere power bank. And if you were the winners of Quiz 2, then your prize is actually wireless Bluetooth AirPods and a pen gift set. All of these items are UJ branded. So please don't forget to send an email to cratilal@uj.ac.za with the relevant information, including the delivery address and a contact number, so that we could get your prizes to you. As we now close the program, I would now like to introduce you to Professor Moronga. Professor Moronga is a Dean of Science at the Nelson Mandela Metropolitan University. He was previously a professor of physics and the director of the UJ Soweto Science Centre at UJ. He completed a Bachelor of Science in Physics at the University of Venda, a Master of Science at the University of Cape Town, and a PhD in Physics at the University of Minnesota. I would now like to hand over to Prof. Moronga, who will be officially closing our program on behalf of NITheCS.
Thank you very much, Dr. Ratila. Let me say greetings to all our wonderful participants, the students, the learners from schools, our panelists, and our distinguished guests. Let me first say greetings from the National Institute of Theoretical and Computational Sciences. Thanks to our program directors and hosts, Dr. Ratilal and Dr. Sitole. And I want to also thank Professor Farai Nyawedza, who actually welcomed us and we felt at home. And to our panelists who gave us great messages from Prof. Christine Jordan, who connected the mathematics in school and how it can be used to solve the problems. Prof. Ibrahim Mononyat, who actually came and tell us that math can be used in various things, from quantifying and interpreting data to finance data and many other areas. I think we have learned a lot from that, and thank you very much. Dr. Andrew Craig, thanks for facilitating the quizzes. That's why we have the winners. You did very well, and it keeps us as the participants wait all the time. And I want to also congratulate all the winners of all our quizzes today. And Mr. Faisal Mohammed, Stats SA, you have demonstrated that without numbers, we will not make sense of the world around us. So thank you very much for presenting the numbers. And it calls on us to use the numbers, especially the scientists and the mathematicians. Whenever we make an argument, we should use the numbers all the time. We have seen that during the COVID-19, that without the numbers, we will not know how risky and how dangerous the COVID-19 was. And Dr. Mamueli Timosia from NRF, she showed us that role modeling is very important. So to the participants, look out at your role model and follow those role models in mathematics. We appreciate the role played by SAASTA and NRF. Dr. Momoton, so thank you very much. Now we understand when we go to the shops and we are scanning through the barcodes, through the scanners, we will realize and recognize your participation here today. The interview by Dr. Ratulal with the Prof. Zarab Janeleze. Thank you very much, Prof. Janeleze. I think that's exactly what we need to convey. The love of what you want to do, the passion that you need to have in order to do mathematics. I think that's very important, because if we do not do that, if we do not speak about the challenges and the processes, then we will be misleading our youth. We need to tell them about the rewards, the spin-offs, the challenges, the difficulties. I'm glad you touched on the difficulties of finding the scholarships, but you also provided the solutions. How should you go about searching for the solutions? Looking for people with a similar research interest. That's very important. NRC President, thank you very much for introducing the Rotary Club to us. And thank you for sponsoring and for announcing the winners, and well done to grade 10 to 11 category, as well as the undergraduate category. You did us proud, and we think that there will be more sponsorships when this event, the IDM, comes again, 2022 and beyond, 2023 and beyond. We are hoping that many people will come and sponsor, and we hope that students and learners who are here will go back and say, look, this is going to happen each and every year. Please come on board. And to Dr. Sonawile for announcing the winners. Once again, well done to all the winners in first prizes and sport prizes for all categories, grade 8 and 9, grade 10 to 12, as well as university category. We are saying halala to you. Well done. You did UJ proud today. And I want to say to the partners of IDM 2022, NITheCS, NRF SAASTA, SAMF, and NRC. Please don't forget to partner with this event again in the future. Thank you very much and well done. And to this day, I'm saying IDM 2022 was a success, and we will meet you next time. Thank you very much.
Thank you, Prof. Maranga. We officially close the program. Thank you all for joining. Stay safe and keep well.
The University of Johannesburg, the future reimagined.